The second way that we can measure spread is by standard deviation. And this is going to be the first big calculation that we're doing in this unit. The good news is, like with a lot of the calculations, I mainly am concerned with, do you understand where the equation comes from? Can you explain the basic idea of the equation? And then can you use a computer to actually do the calculating? So you don't need to do these by hand. You don't need to practice them. It's good to do a few so that you get a feel for it, but you ultimately don't need to be able to be crunching lots of numbers. So again, with spread, we're talking about how similar the data is. So standard deviation. This is the most common measure of spread that we're going to look at in this class. And the ways that you'll see it is either with the textbook uses the letter S, lowercase s. Outside of the textbook, you're going to typically see a lowercase sigma. And it assigns a single number to the spread. So if you remember from when we talk about quartiles and 5 number summaries, that describes spread, but it does it with 5 numbers. Standard deviation is a single number to describe the spread. So it's going to lose some nuance, but it's also going to capture some different things. That's why we use both, depending on the situation. So a second idea that we want to talk about first is actually variance. So variance is s squared. So if you square the standard deviation, you get variance. And this is really because the variance is a little easier to show, and then we can backtrack to standard deviation. That means if we use sigma instead, it's also sigma squared. And variance is calculated. So again, these two variables are the same. I'm going to list them both. By taking the value, by taking a measurement, subtracting the mean, and squaring it. Then take your second measurement, subtract the mean, square it, and continue until you've done this for all of your measurements. Add them all up and then divide by n minus 1. And if you want to write this more compactly and you're familiar with sigma notation, it can be also written like so. So variance, you can kind of think about it like an average of how far the numbers are from the mean. So if we look x minus x bar, that gives us how far we are away from the mean. Then we square it so that they're all positive. And if we add those all up, we get a number that's roughly speaking the total distance that, like if we add all the numbers to get all of the distances added together. And then we divide by n minus 1 for a complex statistical reason. If you want to talk about it one-on-one or in small groups, we can, but for now just take it as we're basically averaging distances. So we divide by the number of measurements we have, and that ends up giving us this variance, which, like I said, is basically an average of how far numbers are from the mean. Now, because of this squared, because of this n1, it's not a true average, but that's the rough idea. The standard deviation is just the square root of the variance. So if you go back to the previous equation and just slap a square root on it, you get s equals, or sigma equals the square root of the first data point minus the mean squared, plus the second data point minus the mean squared, plus do that for all your data points. Finally, the last data point minus the mean squared, all divided by, again, n minus 1. This is the place that most people will mess up when calculating the standard deviation. If you want that in more compact sigma notation, it is like this. And again, you don't necessarily need to be able to do this. The main thing I want you to understand is the variance is kind of like an average, and this is kind of like the square root of the average. It's difficult to develop an intuition of what this means or what this shows until we start using it in calculations, and then you can start to say like, oh, that's why this number is useful. So for now, just kind of, like I said, roll with me on thinking it's kind of like the average distance from the mean. And as we go on, you'll see more nuance to that description. In the meantime, some properties to know. It uses the mean. You saw the mean was in there. So it is sensitive to outliers. If you have outliers, they will make your standard deviation get really big very easily. If s equals 0, that means all the values are identical. So the only way that you can get a standard deviation of 0 is if all the values are the same, because that means the mean is equal to that value, which means for each measurement, value minus mean is 0. You add all those up, divide it by n minus 1, you still get 0, so it's 0. If there's any sort of difference in the numbers, you will get some standard deviation. And this is best used for symmetric, non-skewed data. So we'll talk about a whole bunch of stuff in this class that relates to what we call a normal curve, and that's a special statistical word that when we get to it, I'll explain. This is the place where standard deviation tells us a whole lot about the data. And so for now, just kind of bear along with the idea of this is kind of like an average distance from the mean. And like I said, as we go, you'll see more and more how it applies.